Hi, my name is Moowon.
And my name is Zhang.
We're going to talk about solar photovoltaic technology. And here's an overview. Different types of photovoltaic cells, types of PV cell, PV models, standalone system, grid-tied system, economical and environmental impacts, and new applications. So what is a solar cell? A solar cell is a device that converts sunlight energy into electrical energy. So how does a solar cell work? Uh, in, uh, Inside the solar cell, there are N types and P types. And N-type silicon has free electrons, and P-type silicon has free holes. And when the solar cell is exposed to the sunlight, the N-type and P-type they come together, and when they contact each other, they form an electric field. And to make a solar panel, one or more solar cells need to be connected. And there are two different ways to connect solar cells. One's in series and one's in parallel. When you connect solar cells in series, the voltage of solar cells add up. So for example, if you have a solar cell that generates 1 volt, and if you connect two solar cells in series, then it will add up to 2 volts. And it will also generate more power, but the current will stay constant. And when solar cells are connected in parallel, the current adds up, but the voltage stays constant. And some advantages of using connecting solar cells in parallel are they give more current capacity. As a result, more power can be stored. And there are two major different types of PV cells. One silicon-based PV, and monocrystalline and polycrystalline are two types of silicon-based PV. And another one is thin film PV. And there are also other different types of PV cells. For example, gallium arsenide and cadmium sulfide are other examples of solar cells. And as you can see on this table shows efficiency, different types of solar cells regarding efficiencies. And so typical silicon solar cell, it has about 12% of efficiency, and a silicon cell that's mostly used in commercial, that has about 15% efficiency. And as you can see at the very far bottom, divided spectrum type or multi-junction, that has the highest efficiencies, which is 30%. So PV model, there are PV panels and PV array. So PV panel is a collection of solar cells, and PV array is a collection of solar panels, and it takes quite a lot of space. And how is gonna talk about the next slides?
Okay, I'm going to talk about the PV system, the standalone PV system, and the grid-connected PV system. Let's look at the standalone PV system first. After energy is converted from sunlight to electricity by the PV cell, it's transmitted to the load through a regulator. It operates independently from the utility network. It is a good option for supplying electricity in a remote area. The simplest type of a standalone PV system is a direct coupled system where the DC output of a PV module or array is directly connected to the DC load. We can use battery storage to extend the availability and increase the flexibility. Let's look at the grid-connected PV system. And for application in the residential area, for instance, the rooftop solar panel is considered as small-scale PV, and it's not sufficient enough to power the entire house or building independently. So it's necessary to connect it to the utility service network as an alternative energy source and backup. This diagram here shows how the PV system works together with the utility network and other energy sources like the wind turbine system. Basically, they are all gonna charge the battery and eventually to power the load. For the economical impact, there are two major type of PV technology. The silicon-based PV technology, for example, the monocrystalline and the polycrystalline, they are expensive, but they have high efficiency. On the other hand, the thin film cells, they are cheaper compared to the silicon-based technology, but they have a low efficiency. And here is a typical example of how the market affects the development of this technology. Let's look at the price of the polycrystalline silicon. In 2005, the price was $35 per kilogram. And at that price, it attracted a lot of investment. So it grew rapidly during that time. Meanwhile, the price also went up to $480 per kilogram right before the economic crisis in 2008. And because of that, people started looking for other energy sources, cheaper options. After the recession, the price went down to $70 per kilogram in 2010, and that gives the advantage of this technology to more development. Now, Moowon going to talk about the environmental impact.
Although solar panels are environmentally friendly, there are also some negative aspects. It needs a large amount of energy to produce solar panels, and the production creates greenhouse gases. And crystalline PV contains cadmium, which is harmful to the environment, and it might cause cadmium poisoning. And thin film PV requires rare metals, and PV panels takes large space. For example, it takes 1 square kilometer of solar panels to produce 20 to 60 megawatts. Building integrated PV. Solar panels can be used for roof skylights. They replace conventional building material in parts of the building envelope. They use semi-transparent solar module, and skylights and PV glass windows are two examples. And either off-grid or grid-tied system can be used. And semi-transparent PV, these two pictures shows examples of using solar panels. The picture on the left side shows that solar panels can be used instead of window, and the picture on the right side shows that solar panels can be placed on the roof. In conclusion, solar panels are a reliable energy source, and it is very environmental friendly, but there are some concerns that should be more developed. These are the references that we have used, and thank you very much.